Our next topic is pen and ink illustrations and pen and ink textures. And the work we introduce here is titled Vignette. The problem we want to address here is that it is tedious to draw detailed patterns manually. So if you want to draw these kind of patterns using your pen, you have to draw every details, which is very tedious. And one possible approach is to copy and paste to generate repeated pattern, but the repetition is visible and looks too unnatural. So approach is to use example-based texture synthesis technique published in 2011. So using this technique and combining interaction technique, you can draw this kind of repeated patterns very quickly and efficiently. Let me show you a video, demo. So if you pick a standard pen, this is just a standard inking system. However, you can also generate a patterns like this way. So suppose you draw this kind of pattern, and then after you get this, you can extend it this way and also this way. So after the identifying pattern, you can draw many instances just by drawing. And another example is this one. So you specify a region first, and then you draw patterns. Then after having a pattern, you can repeat it like this way, and then you will get pattern automatically. And another interesting feature is like this. So you select a region, and then you paint individual elements like this. Suppose you have bricks like this way. Maybe enough. And then you can get patterns like this way. And after that, you can tilt it like this kind of 3D effect. So this operation only happens inside this region. But in this way, you can get kind of three-dimensional effect within the region. Another possible operation is hatching. So you first select a region, and then you draw example strokes like this way, and this way, so on. And then you select these two, and then you get this kind of hatching pattern. And then you can also draw in different directions, and then you get this kind of hatching pattern very easily. So let me show you a video. So here, so you draw example sketches, and then you draw a line, and the system automatically synthesizes the same pattern, and you can repeat it many times. And again, you paint an example, and then system requests the desired path, and then system synthesizes the same stroke. So in this way, a user can paint many strokes without drawing individual strokes. And the most important part here is the seamless integration of example generation and then synthesis part. And here's another example. So you draw a few examples, and the system synthesizes the rest. And after the synthesis, you can go back to the texture element, and you can add more details, and it's automatically applied to the synthesis result. Then you can also change the density, and also you can change the curve shape later. And next example is flood fill synthesis. Again, you draw a very few elements, an example, and then system automatically synthesize the same texture to fill the region. And after that, if you want, you can change the flow orientation just by drawing strokes, and then texture will be modified to follow the flow direction. And again, you can change the details later. And here's an example of hatching. You draw a few examples and then system predicts it. And after that, in order to provide three-dimensional effect, you can use a tilting tool. And then given a two-dimensional drawing, you can add a kind of perspective effect for individual regions. And here's a couple example operations. So you paint this. And then you can get many hairs just by sketching. And then flood fill can be useful for the background. And here's the result. Here's another example. So you draw examples and then fill the region. And then you can use a perspective tilting to give more like a three-dimensional effect. And then background can be painted using the texture synthesis. And here's the result. So that's a video. And here's a couple of results painted by test users. So you can get this kind of sketches with many repetitions using this kind of automatic texture synthesis. So this is one example, and this is another. You can get very detailed hairs and very detailed background and hatching and so on. And you can also get this. So I think 3D effect is used here and here. And the technique we use here is called discrete element texture synthesis. And so their technique takes input layout, example layout, and then it automatically synthesizes new, larger layout automatically without explicit repetitions. And what they do is basically iterative refinement. It starts with just simple repetitions, patch and copy, repeated patterns, but gradually improves it, and then you finally get a very beautiful result. And for each step, we do this. So each step we repeat this. So first, for each element in the synthesized image, we look for an element in the source image with similar neighborhood or similar context. So suppose you have an element here, and you have circle and box in this arrangement. You try to find the more similar arrangement. So that's a matching phase. After identifying a match, then you compare the context. So this is the synthesized context, and this is original context. And then you compare these two, and then try to find the ideal position for the surrounding object. For example, this box should be more to the left to be similar to the source. So in this way, you compute ideal positions or target positions for individual element for each match. And individual element belongs to multiple matches. So we simply take average of all the related ideal or target positions and then move the object to the target position. So by repeating them, then you will get this kind of result. So starting from simple multi-copies, and then you get a seamless patches. Okay, so that's a brief description of the system called BigNet. The original paper was published as interactive texture design manipulation with free-form gestures for pen and ink illustration. And then the technique we used is called element texture synthesis. and it was introduced in at SIGGRAPH at 2011. Thank you.